we say that in this whole universe, nothing can travel through space faster than the speed of light. And the speed of light is 2997 and 2458 meter per second. And that's a huge number. And in terms of universe, it's not even huge. So, but yet, it's still the fastest thing in this whole universe. Nothing can travel through space faster than the speed of light. Now, however, that is not actually what happens in the quantum mechanics, because quantum mechanics possesses a different set of rules that are not there in this real world. Because if you say the same thing, that is nothing can travel faster than the speed of light, that same thing may not be applicable in the realm of quantum mechanics, because informations in quantum mechanics indeed travel faster than the speed of light. Like how, remember we did the example, we visualized the example, this 0 and 1 scenario. If this is 1 and this is 0, and I close my hand, close my wrist, and like first of all I shuffled it, and I do not know, I do not have any idea, I do not have any precise knowledge about these states, at like which hand contains which state. I do not know anything. Now, the moment I open it, it has 0 now. So this was in superposition, and this now has collapsed into being one state. So it will be 1, because this was 0, this is 0. So it is right there, it is 1. Now, again I shuffled it, okay. I do not know, I do not have any precise knowledge about which state contained within which hand. So irrespective of the distance that these two states are separated apart from each other, like you can throw it anywhere in the universe, you can throw any of the state anywhere in the universe, but yet the moment you open any one of the state, you will have the idea of the other state. It's like that information has communicated by the one state into the other state faster than the speed of light. That means if I open it, let's say this is very very far away, this is like in different sets of galaxies, like I have thrown it away and I open it, it's now 0. It's 0. So it's like it's 0, and this state has communicated faster than the speed of light to the other state that you cannot be 0, you have to be 1. And now that's where this state becomes 1. That means in quantum mechanics, information can indeed travel faster than the speed of light, and that is what quantum mechanics deal with. And it's a huge complex and intriguing concept of quantum mechanics. Superposition, information traveling faster than the speed of light. Now to understand this quantum mechanics phenomena of superposition, entanglement, things traveling faster than the speed of light, you can actually visualize this with an example. Let's say we have a quantum coin, and this coin can have two possibilities. If I flip it, if I toss it, this coin can land on heads, and the other possibility will be tail. So they're basically 50% of being 1. So this coin right here, this can be either 50% times head and 50% time tail, because there are two actual outcomes of this coin. Now, let's say if this is a quantum coin, this is a Q.coin, quantum coin, and the same way that we have encountered those 0-1 thing, we can encounter this head and tail thing. So if I separated these two states, because it's quantum mechanics, so I've separated these two states of this coin. Now I have one straight head and I have the other straight tail. So without having to know every state, every possible state, I just need to know the one state of this coin. If this is head, I will know for sure that the other state will be tail, irrespective of the distance between them. Even the distance between them may be 4 lakh kilometer, 5 lakh kilometer, 4 crore kilometer, like be it any. Literally, these two states can have an infinite distance between them, and yet just by knowing the one state, you will have the precise idea of the other states, and that is what quantum mechanics is. So the moment you are not observing these two states of coin, every state, that means two states, are existing in superposition. So it was head and tail, like it's simultaneously. So the moment you observed it to be head, that means it cannot be tail. This other state was in superposition, and now since this is head, this cannot be head, so this has to be tail. So it collapsed. So the other state has now collapsed from being in superposition of head and tail now to being tail, only one state at a time. That's quantum mechanics. So in terms of quantum mechanics, we don't play with this 0-1 thing, or we don't play with this head or tail thing. We actually play with the spins of electron. Like as of now, if we know the spin of an electron, where like if it is spinning clockwise, we will have the precise idea of this electrons entangled pair, irrespective of how far that other pair is. We'll know for sure that if this is clockwise, the other entangled pair of this electron will be in counterclockwise. Because to be able to compensate with these two rotations, they have to be zero to be able to be in a stable position. So this clockwise rotation of one electron will cancel out the counterclockwise rotation of the other paired entangled electron. So that's what basically we play with in quantum mechanics. Now, quantum mechanics allows teleportation. Let me show you how. See, consider this is a box, and there is a small particle here. And in quantum mechanics, we cannot be very sure that a particle will be here. That means a particle within a box can be literally everywhere at the same time. So this particle can be here, anywhere. Until we open the box and found out that okay, that's particle here. Before opening the box, that particle was existing in superposition in multiple states. Like this particle was here, and literally everywhere. Now, how quantum mechanics allow teleportation and quantum tunneling is also a concept related to this. So, there's also a slight chance of possibility that this particle may pass right through the walls of the box and be outside the box, and that is what is called quantum tunneling. It is quantum tunneling, and it is possible in quantum mechanics, like to pass right through any wall. However, the chances of passing right through a wall is very less, but yet not zero. It is still possible, and that's again quantum mechanics.